Hello, class. You are welcome to this session on graphical presentation of data. As mentioned earlier, when you have your data in statistics, the descriptive part of your statistical analysis requires that you organize your data. And one way of organizing your data is to present your data in graphs. So there are a number of graphs and charts we will be considering in this session. We will look at simple bar charts, multiple bar charts, simple bar charts, multiple bar charts, component bar charts, percentage bar charts, a line graph, a histogram, frequency polygon, cumulative frequency polygon, and also the stem and leaf plots. So let's begin with a simple bar chart. As the word goes, it is a chart that is very simple. It gives you a chart which has bars. So this is a simple bar chart. We have a chart where you have your bars indicating particular measures as against the count of those measures. So in this example, we were looking at months and the number of eggs sold in a particular month. In the month of January, we had 10 crates of eggs sold. February, we had 35 crates of eggs, and so on. So if you want to represent this data in the form of a graph, you can use a simple bar chart. And this is how it is illustrated, all right? So you realize that in this chart, we have our horizontal axis and then our vertical axis. And the count is from January has 10, that's a least count, and April has 50, that's a maximum count. So you label your vertical axis such that it features both, it runs from both your minimum to at least your maximum. The maximum count was 50, but we exceeded it by 10. You can do that by just a little margin. But you need to make sure that your minimum counts and the maximum counts are included in your labeling, and your labeling has to be even. You realize that this is a count of 10, 10, so 0 to 10, 10 to 20, 20 to 30, and so forth. So the distribution of counts on your vertical axis has to be even. When it comes to your horizontal axis, in this case, which is our months, we have from January to May. So January has its bar, February has its bar, March has its bar, and so on. If you look at the data, for example, the month of January, 10 eggs were sold, all right? So you have January here, and the count is 10. So you draw your bar to as against the number of counts of eggs you are looking at. If you look at the month of March, for example, March had 40 counts, okay? So when we come to March, for example, when you should trace it up, you see that March has counts of 40 ends there. So if you are putting together a simple bar chart with a simple list of data such as this is how you go about it. Shall we now look at our multiple bar charts? Okay, this is an extension of our simple bar charts. All right. So in this case, if you look at this table, we have the months, but we don't just have eggs. We have brown eggs and white eggs. So for every month, we are now decomposing the count of eggs into the various distinctions in there. So in the month of January, there is a need to indicate how many brown eggs were sold and how many white eggs were sold, instead of just counting number of crates of eggs sold. So in January, we had 10 brown eggs and then 5 white eggs. In February, we had 35 brown eggs and then 37 white eggs, and so on for the other months. So if you have a data distribution like this and you want to draw a chart out of it, there's a need for you want to present all of them in one chart. You can use two simple bar charts. So you consider January, the month, and brown eggs in a simple bar chart, and then month against white eggs in another bar chart. But if you want to compress them all into one chart, a multiple bar chart can be useful. So in this case, we have a multiple bar chart. If you look at your data, you will see that in the month of January, we have the blue bars representing the brown eggs and the green bars representing the white eggs, okay? So in this case, in the month of January, there were 10, if you look at your table, there were 10 brown eggs and 5 white eggs. So we have the blue 10 brown eggs and then the white eggs 5. That's in the middle of 0 and 10. That's 5. In the month of February, there were, no, let's look at March. In the month of March, there were 40 brown eggs and 45 white eggs. So from your table, you see that in the month of March, there are 40 brown eggs and then 45 white eggs. So this is how you can also put together your multiple bar charts. You take the month, you label it as such, and because against each month, there are 2 categories of eggs you are looking at, you will draw different bars for each month, but they should be together like this. So in the month of January, you have your brown eggs and your white eggs. February, you have your brown eggs and white eggs according to the number of counts that is given, okay? In the case of exam, you may not have colors and all of that to show it graphically beautifully like this. So I can please give me a moment. Great. So in the case of somewhat in your exam, you may not have colors to show. So there's a way you can work it with your pen or your pencil. Right. So let me demonstrate it here. We have here a multiple bar chart. So we have the month of January, and we have here 10, 20, 30, 40. All right. So let's take just a few of the months. Okay, January. In the month of January, the number of brown eggs were 10. And the number of white eggs were 5 to 0. Okay. So since we don't have colors, let's do for February too. February, number of brown eggs were 35. Number of white eggs were 37. So I'm going to draw my key. Instead of using colors, I would say the dots are for brown eggs, and then the lines are for white eggs. So to distinguish, I make dots in here, which stands for brown eggs. Okay. Then I make lines in here for white eggs. So in the absence of having colors, this is how you can distinguish your brown eggs from your white eggs. You can use any form of distinction. Just make sure that all brown eggs have the same key, and then all white eggs have the same key. And in exam, you need to indicate your key. If you just do this without showing me that the dots means brown eggs and the lines means white eggs, your examiner will not understand what you are trying to do, or somebody who is studying what you are doing will not appreciate what you have done. So it's very important that you give the keys, you write the keys under your graph. All right. Okay, so can we move on to the next chart? The next chart is the component bar charts. Component bar charts. So in this particular chart, you see that it's different from a multiple bar chart. The graphs are not drawn against each other. Rather, the graphs are drawn on top of each other, okay? So you have an example of a table here, the same previous example where we have our months, the number of brown eggs, number of white eggs, and the total number of eggs, okay? So if you look at 10 plus 5, we have 15, 35 plus 37 is 72, and so on. So what does a component bar chart do, or how does it show up? A component bar chart allows you to draw two different or represent two different data on the same graph and simultaneously showing you the total count of these two different data, all right? So in this particular chart, you see the brown eggs are in the blue section, white eggs are in green. For the month of January, brown eggs were 10, white eggs were 5, total were 15. So you're looking at this chart alone. If you do your vertical labeling well, all right, you can see that in January, brown eggs were just in the middle of 0 and 20, that's 10. And then this small green is from 10 to, it's just in the middle of 10 and 20, which is 5. So indeed, you can tell that there are 5 white eggs and then 10 brown eggs. And you can also get a total count. So from this here all the way, the bottom here all the way to the top of this bar, you can see that it counts 15 of them, which showing the total number of eggs in the month of January is 15. So component bar chart allows you to represent different kinds of data on the same graph, while at the same time giving you the total number of counts together for each category. If you look at the month of May, for example, there were 30 brown eggs. Let's look at April. April seems a bit easier. There were 50 brown eggs and 50 white eggs. It's a total of 100. April. So if you look at the month of April, brown eggs, you count from 0 all the way to middle of 40 and 60, which is 50, all right? And then from 50 all the way to 100 is also 50. So it shows that there are 50 white eggs and 50 brown eggs. And if you count from 0 all the way to the top, you have 100, which shows that the total count of eggs sold is 100. The component bar chart is also a very interesting way of presenting your data to make a lot of meaning to yourself or your viewers. So in the same ways, if you can't use colors, use a different way of notation to distinguish between your brown eggs and your white eggs. Let us now look at percentage bar charts. Percentage bar charts. With percentage bar charts, we want to view our data in percentage form. So it's similar to component bar charts, but in component bar charts, we use the raw data. However, under percentage bar charts, we use the percentages of the data. So it's important for you to convert your data, first of all, into percentages. In this example, from our previous example, all right, we have the months, number of brown eggs, 10, 35, 40, 50, number of white eggs, 5, 37, 45, and then the total. However, because we want to present our work as a percentage bar chart, we will convert these figures to percentages. So First of all, how did we get 7% or 33%? You have to take your count of brown here out of the total in this particular month and you multiply it by 100. And that will give you your 7%. Same for this, 5 out of 15 times 100 gives you your 33%, okay? So in the case of, let me do a little bit of illustration. So we have our month. And then our brown eggs. Then our white eggs. Total. So let's say the month of January. The count is 10 for brown eggs, it's 5 for white eggs, and it's 15 for the total. And if you look at the month of April, okay, yeah, let's just do the next one, okay? So the month of February, there were 35, 37 for white, total of 72. So how do I find the percentages? For example, under January, to find the percentage of eggs that are brown, I take the count of brown, which is 10, divided by the total number of eggs in January, and multiply by 100. And if you use your calculators, you can see that this is going to give you 67, okay, percent. So we write here 67%. The number of white eggs in the month of January, we have 5 of them out of the total of 15 times 100%, which is equal to 33%. However, since there are just two sections, okay, we're looking at just brown eggs and white eggs. Once I get my percentage for brown eggs, I can simply subtract this number from 100%. And that's 100 minus 67 equals 33, which gives me 33%. So I can skip this session, this procedure. Same works for, so this is month of January, month of February, it works the same way. The number of counts of brown eggs in February is 35, total is 72 times 100%, and that gives us 49%. Like I write it here. Then as I said, for white eggs, we can simply subtract 49% from 100%, and that will give us 51%, because there are just two categories involved, okay? The value is 51%. Okay. So this is how you can move on to fill in for the other months to get your percentage, your percentages into your table. So at this point, after you have filled in your table in the percentages, we are now going to work with percentages only, no more the actual counts. So the month of January, so definitely in your table, you have to label from 0% to 100%. And then you label your categories, January, February, March, April, May, indicate what represents brown eggs and what represents white eggs based on whatever form of key you would use. Whether you're using colors or you're using dots and lines or you're shading. So in the month of January, brown eggs is 67%, white eggs is 33%, total 100%. So we have January brown eggs 67%. So you do your best to get the accurate count of brown eggs up to this point. Then definitely as I said, there are just two categories involved. So the rest simply is white eggs. So you can simply shade up to 100%. But if you actually check, you will see that from here to here is 33%, which represents the month of January. Okay. Let's take the month of March. In the month of March, percentage of brown eggs is 47%, percentage of white eggs is 53%. So March, we are here. Percentage of brown eggs is 47. So you do your best to reach 47%. Then the rest, which is 53%, is your white eggs percentage. If you actually check from here to where the green starts, you will see that it's actually 53%. Okay. So this is how you also go about a percentage bar chart. The next chart we want to look at is a line graph, a simple line graph. So in the case of a line graph, you may have a list of months and the number of eggs. So we have months from January to December, January, February, March, April, so on, November, and then December, and the number of crates of eggs sold for each of these months. So if you want to present this as a line graph, which is also a graphical way of presenting your data, you have to present this in a graph like this, where your vertical axis represents the number of eggs, and then your horizontal axis represents your month. So you have your months labeled on your horizontal axis. And if you look at our table, the least count of eggs is 4, and the maximum count of eggs is 20. So in drawing your vertical axis, you should make sure that 4 falls within and 20 also falls within. Here we extended it a bit to 25. Okay. All right. So at this point, what we do is the month of January is 4. So we come to our line graph and see that indeed January, if you count it, this is it looks more, yes, it's at 4. We don't have a lot of lines to really give us accurate, but this is a good estimation of the count of January. If you look at the month of February, we have a count of 8. So let's see, February, could this be 8? Yes, this really is at the point of 8, okay? Let's look at the month of January, February, March, April, May. This month, May had a count of 20. So if you go down, you see that the month of May here up to 20, and that is right. So this is how you do it. You take each month, look at its count, and make a dot there. After you've made all the dots, you use your rule to connect all the dots consecutively. So connect from January to February, February to March, March to April, April to May, until you reach December. So this is a line graph, another way of presenting your data as a graph. We can also present our data in the form of a histogram. We'll illustrate the histogram right here. I couldn't draw it for you. So when drawing a histogram, you need your histogram. Usually we use it when our data is in a form of grouped, okay? It's a group data form, as we see in this table. And then we have here our class boundaries. Okay, so we also have our frequencies. That's number of counts between 1 and 5. There are 3 of them. Number of counts between 6 and 10. There are 7 of them. So 7 of them have data running between 6 and 10. 20 people have data running between 21 and 25. This can be anything. It could be ages. So if in case it's ages, we are saying that 20 people have their ages falling between age 21 and 25. 15 people have their ages falling between age 31 and 35, and so on. How do you get class boundaries? Get class boundaries by adding we call, for every class interval, the number to your left is the lower limit. The number to your right is your upper limit. So you add the upper limit of, take 2 intervals, 2 consecutive intervals. You can see that these intervals are very regular, 1 to 5, 6 to 10, 11 to 15. They each have a gap of 4. So 5 minus 1 is 4, 10 minus 6 is 4. So each of them have they are evenly distributed as an interval. So once it's that way, you pick the upper limits of your, take any two intervals, pick the upper limits of the first one, and then pick the lower limit of the second one. So the upper limit of the first interval here is 5, lower limit is 6. 5 plus 6. And then once you consider these two, you divide it. First of all, pardon me, okay? Once you consider your upper limit of the first interval and the lower limit of your second interval, the difference between the two, 6 minus 5, is 1. And then you divide what's that difference by 2. And then 1 divided by 2 is 0.5. So with that 0.5, you take every interval, the lower limit you subtract 0.5, and the upper limit you add the 0.5. So if you're using 0.5, look at the first interval. 1 minus 0.5 is 0.5, but 5 plus 0.5 is 5.5. Look at 16 to 20. 16 minus 0.5 is 15.5. 20 plus 0.5 is 20.5. So this is how you get your class boundaries for each class interval. So most important is identify two intervals, find the upper limit of the first interval, consider the lower limit of the second interval, find their difference, divide their difference by 2 to give you your margin of difference you are working with. And once you have that, you subtract that from your lower interval and you add it all to your upper interval of every class interval. This is how you fill your class boundary column. And this is your frequency column. So at this point, how do we draw a histogram? So for a histogram, what you do is, as usual, you label your vertical axis and label your horizontal axis. On your vertical axis, you have your frequency. In our table, if you look at your table, you see that the lower count is 3, the upper count is 22. So I'll try and label to about 25. And I'll let my gap be 5, 5, 5. So 5, 10, 15, 20. Let me remove this. And then 25. But on your horizontal axis, so here we call it frequency. But on your horizontal axis, you have your class boundaries. So we use class boundaries to draw a histogram. So it's very important you create that column in your table. We start from for the first interval, the lower class boundary is 0.5. The upper class boundary is 5.5. So the frequency for this interval is 3. So I trace it up. I think this is 3. Then I draw my first. The second interval, lower class boundary is 5.5. So I don't write anything. Upper class boundary is 10.5. And the frequency is 7. So I trace it up to 7. It's about 7. And then the third interval, class boundary is 10.5 to 15.5. Frequency is 17. So I move up. This is about 17. And then we have it. So you do it this way for all the intervals. We realize that by the time you are done, the histogram doesn't have any spaces between the bars. The bars are together because we are using the class boundaries. So that's how you go. But let's do that one more, 15.5 to 20.5. The frequency is 22. So we move up. It should be 22. This is a sketch, okay? And you can have a proper graph sheet and you can do a better sketch than I am doing. So this is how we can put together a histogram. All right. The next graph we want to look at is frequency polygon. Frequency polygon. In drawing frequency polygon, so in all these graphs, what matters is what graph am I drawing? That's the first question. What graph am I drawing? And what are the components I need to draw this graph? What are the requirements for this graph? Okay, that is what the question you should ask yourself. When it comes to frequency polygon, you need your class midpoints and then your frequencies. So if you look at this data, we have class intervals, class midpoints, and frequencies. How do you get your class midpoint? That's simply going to, for each interval, sum the lower limits plus the upper limits, divide by 2. So in this case, 1 plus 5 is 6. 6 divided by 2 is 3. Look at 11 and 15. 11 plus 15 is 26. 26 divided by 2 is 13. So you sum your lower limits and your upper limits, divide by 2, and that gives you your class midpoint. Once you have your class midpoints and your frequencies, you are good to go. You come to your table. Your vertical axis is your frequency. Your horizontal is your class midpoint. So you pick a particular class midpoint, which is 3. Its frequency is 3. So 3 frequency is 3. All right, 3 frequency is 3. Look at this class midpoint of 18. Its frequency is 22. Let's come back here. 18 is here. Its frequency is 22. If you look at midpoint of 43, the last one, its frequency is 5. Okay, so 43, its frequency is 5. So once you come out to the class midpoints and you label them like this and you indicate their frequencies with dots, you take your ruler and you connect all the dots accordingly. Okay, so this is how you draw your frequency polygon. Another graph you can consider is the cumulative frequency curve. The cumulative frequency curve, another word for it is the ogive, okay? What are the components of a cumulative frequency curve? You will need your upper class boundaries and your cumulative frequencies. What are these? If you look at this table, we have already indicated how to come out with our class boundaries. We have our class intervals. What are the upper class boundaries? They are the upper class boundaries of each interval. So if you look at the first interval, we have 0.5 to 5.5. The upper class boundary is definitely 5.5. If you look at this interval, 10.5 and 15.5, the upper class boundary is 15.5. So you pick all the boundaries on the right-hand side like this, because these are all the upper class boundaries for each specific interval. We already have our frequencies. How do you get a cumulative frequencies? You sum up every frequency. You sum up all the frequencies up to the level of cumulative frequency you are looking for. So for the first one, it's just one count. So one cumulative frequency is 1. For the second one, which is 4, we summed up all the frequencies up to this level. So 1 plus 3, which is 4. The next one is 21. You sum it 1 plus 3 plus 17. That gives you 21. So if you look at this one, 91, it is a sum of 1, 3, 17, all the way to this last point, which is 13. If you sum all the way from 1 to 13, you are going to get 91. So this is how you put together your cumulative frequency. And once you have your upper class boundary and your cumulative frequency, your cumulative frequency curve is done, because you will need to know the label your cumulative frequencies. It lasts from 1 to 100. So your vertical axis must span from 0 to at least 100. And then your upper class boundaries, you start labeling. So you look at the counts that you have. It's from 5.5 to 45.5. So we have 5.5. Its count is 1. So we have our 1. Okay. Sorry. But 5.5, its count is 1. If you look at the next one, 4, its frequency is 3. So, sorry, 10.5, its frequency is 4. So don't forget the columns you are working with. You are working with upper class boundaries and then cumulative frequency, okay? So for the upper class boundary, which is on your horizontal axis, if you look at 10.5, its cumulative frequency is 4. So you come to the curve, you have 10.5 with its cumulative frequency being 4. Let's take one more. If you look at the upper class boundary, 20.5, its cumulative frequency is 43. So let's come. 20.5, do we have 43? Yes, this is very close to or about 43. So this is how you draw your cumulative frequency curve. Once you have your dot connected to all your upper class boundaries, you simply use your ruler to join all the curves together. You realize that cumulative frequency curve, it doesn't fall. It keeps ascending so it reaches its limits, okay? So this is how a cumulative frequency curve is also drawn, all right? The final thing we want to look at is the stem and leaf plot. The stem and leaf plot. Now, this is a plot that is, it's a another way of presenting your data. Okay, so I'll go straight away instead of doing it here, explaining it here. Let me go straight away and then illustrate it for you to see. So I may have a list of data points. First of all, you can get your data out of a stem and leaf plot, or you can convert your data into a stem and leaf plot. If you look at the table that we have in our notes, we have a stem and leaf plot with a table like this. One, two, three, four. This is all I'll do. Okay, I've cut it short. 1, 1, 3, 3, 6, 0, 0, 2, 3, 4. Then 5, 5, 5, 6, 8, 8, 9, 9, 9. How do I collect data out of this table? The stem here is indicating the first number. The second here is indicating the second number, okay? So this table is showing that all the numbers are in tens, all right? So if you look at the first one, we have 1, which are the dipping parts, okay? The dipping parts, the left-hand side of a table. We call this section the stem. This is the stem, okay? And then this side, the right-hand side here is the leaf. So the circled part is the stem. So if you look at the first row, the first one is 1. And then if you come to the aspects of the leaf, we have 1. And then again, there's 1 and then 1. Then there's 1 and then 3. And then there's 1 and then 3. Okay. Look at the second row. The stem is 2. So it means all the numbers are 20 something, 20 something. So it's 26. And that's it. Look at the third one. The stem is 3. It means all the numbers are 30 something, 30 something, 30 something. So the first one is 30, which is 30. Then 30 again, 30. Then 32, which is 32. 33, 33. 34, 34. How about the fourth one? We have 4 something. 4 is in the stem, which means all the numbers are 40 something. So we'll have 45, 45, 45, 46, and so on. So this is how, at this point, all this data here is showing me the actual data that I created this stem and leaf plot with, all right? So you can also have this data and convert it into a stem and leaf plot. I think that would be good for you to practice for further understanding. Thank you for being a part of this class. We will continue another time.